So welcome to the first lesson. We're going to call this lesson 1. So don't worry about it calling 1, 2. That was from our old unit. This lesson is going to cover uh, evaluating expressions and collecting like terms, essentially. So hopefully a little refreshing practice with that stuff before we get back into the unit that we had started in the new system. First thing we're talking about is a variable. It's a symbol, which is almost always a letter, typically like X, Y, Z, A, B, C, something like that, that represents one or more numbers. An expression that contains one or more variables is an algebraic expression. So for instance, 7x minus 3xy, that is an algebraic expression because it's got variables in it. When you're being asked to evaluate, that's code for substitute. So -2 is going to get substituted in for x, and the 5 is going to get substituted in for the y. So when I go ahead and do 7 times -2 minus 3 times -2 times 5. Again, those numbers substitute in for those variables. Now I'm just simplifying based on order of operations. So multiplication needs to happen first, and then the subtraction can happen. So I've got -14. 7 times -2 is -14. The subtraction will happen later. So I'm going to only multiply the 3, not the -3. It's subtraction, so it's just subtracting +3. So +3 times -2 is -6. -6 times 5 is -30. -14 minus -30. Now I can do subtraction. I'm actually going to turn that into addition. Subtracting a negative is adding. And you end up with -16. All right. So then we look at this one. Same deal. We're substituting 6 in for k in the expression. Only one variable this time. So it would be 6 minus 18 squared minus 4 times 6. The order of operations would have you do inside parentheses first, so that would be -12. Then it would have you do exponents. So -12 squared is 144. Then you would do multiplication before the subtraction. So 4 times 6 is 24. And you end up with 120. All right. This is actually two separate questions. We're going to do z equals 2, substitute z for 2 first, and then we'll substitute -6 in as a separate question. So for z equals 2, you're going to have -3 times 2 squared plus 14 times 2 minus 4. Again, exponents first. Then multiplication, so that'll be -12. That would be 28. Now we can add. Then we can subtract. When z is equal to -6, we're just going to substitute in the same way. Again, it's a separate question. So it's -3 times -6 squared plus 14 times -6 minus 4. -6 squared is 36. Now I can do multiplication. -3 times 36 is -108. 14 times -6 is -84. Then we just subtract across. -108 minus 84 is -192. And then -192 minus 4 is -196. All right, so that would be the first example there. Answer choice D is, I'm sorry, uh, part D of the example is really just kind of a fancy way of asking you to do the same thing. So it gives you an expression. It looks complicated, but we really just have one thing to do with it. So we're not graphing or anything like that. That expression models the percent increase of young voters in a town from 2000 to 2010. In the expression, Y represents the number of years since 2000. Find the approximate percent of increase of young voters by 2008. So based on the definition of Y, if Y is the number of years since 2008, since 2000, and it is 2008, that means Y is going to equal 8 for this. And we're going to take the expression that was given and evaluate it for Y equals 8. So again, it's the same thing we just did, just packaged in a different way. So we're substituting 8 in for Y, and you're going to get this. 8 squared is 64. When I multiply there, you get negative 5.12 plus 24. And then when you add them together, you get you get 18.88. So that would be the percent increase by 2008 for young voters in that town. All right, then just a couple of definitions. A term is a number, so it could be just a number like 3. It could be a variable, just like x, or the product of a number and one or more variables. So something like, I don't know, 5x, y. The variables can have exponents or whatever. What I want you to take out of this is this term is one term. What would separate terms would be a plus or a minus. But even though it has more than one factor, it is still one term, the 5xy squared. A coefficient is the numerical factor in a term. So in this case, the coefficient is 5. Like terms have the same variables raised to the same powers. So 3x and 5x squared are not like terms, even though they both have x. They need to have the same variables. You cannot add those together. Okay. But like 2x and 4x, you could add together because they have the same variable. All right, so I'm going to stop the video now, and I will pick up with a second portion for you to click on.